welcome everyone. So today we will discuss about Indian contributions to science, which is the third chapter of Vigyan Bharati for the examination VVM. So coming to the first chapter of Indian contribution to science and technology. Advancements in science and technology have been the major reason for the development of human civilization. India has been contributing to the fields of science and technology since ancient times. Even today, what we term as traditional knowledge is actually based on scientific reasoning. Pre-independence, the history of scientific discoveries and development in India dates back to the Vedic era. Aryabhatta, the famous mathematician of the Vedic era, invented zero. It is believed that ancient India scholars had developed geometric theorems before Pythagoras had made them popular. The concept of squares, rectangles, circles, triangles, fractions, and the ability to express numbers 10 to the 12th power, algebraic formula, and astronomy have all had their origins in Vedic literature. Some are stated to have been known as early as 1500 BC. The decimal system was already in use during Harappan civilization. This is evident in their use of weights and measures. Moreover, the concepts of astronomy and metaphysics are all described in the Rig Veda, the ancient Hindu text of Vedic era. From the complex layout of Harappan towns to the existence of iron pillar in Delhi, it is evident that India's indigenous technologies had been very sophisticated. They included the design and planning of water supply, traffic flow, natural air conditioning, complex stonework, and constructing engineering. The Indus Valley civilization was the world's first to build planned towns with underground drainage, civil sanitation, hydraulic engineering, and air cooling architecture. While other ancient civilizations of the world were small towns with one central complex, the Indus Valley civilization had the distinction of being spread across a region about half the size of Europe. Weights and linguistic symbols were standardized across this vast geography for a period of over 1000 years, from around 3000 BC to 1500 BC. Water management. Water has been the lifeblood of major civilizations. Crisscrossed by many great rivers, India is no exception to the rule. Indians had been developing water management techniques even before Harappan time. Wells, ponds, lakes, dams, and canals have been constructed with advancement technologies throughout the historic timeline of Indian civilization. Water have been used for storage, drinking, and purpose of irrigation. It is estimated that even today there are more than millions man-made ponds and lakes in India. Iron and steel. Iron and steel have literally been pillars of modern civilization. Ancient India was pioneer in developing the technology of producing rust-free iron. This metal from India was famous in contemporary Europe for sword making. The famous iron pillar of Delhi is a testimony to that technology, which almost rust free even today. Farming techniques and fertilizers. Indian farming technology was mostly indigenous, developed, and was ahead of time. It included soil testing techniques, crop rotation techniques, irrigation plants, application of eco-friendly pesticides and fertilizers, storage methods for crops, etc. Coming to physics, the concept of atoms can be traced to the Vedic times. The material world was divided into five elements, namely earth, that's Prithvi, fire, Agni, air, Vayu, water, Jal, and ether or space, which is Akash. Paramanu, that is beyond atom, was considered to be the smallest particle which cannot be divided further. Nuclear energy is produced today, splitting the same. Medicine and surgery. Ayurveda, Ayur means life and Veda means knowledge, is probably the oldest structured system of medical science in the world. Proper knowledge about various ailments, diseases, symptoms, diagnosis, and cure is the basis of Ayurveda. Many scholars like Charaka and Susruta have made invaluable contributions to Ayurveda by inscribing in written form as found in ancient manuscripts. Shipping and shipbuilding. Shipbuilding was one of India's major export industries till British dismantled it and formally banned it. Medieval Arab sailors purchased boats from India. Even the Portuguese, instead of buying from Europe, also obtained their boats from India. Some of the world's largest and most sophisticated ships were built in India and China. The compass and other navigation tools were already in use in India much before Europe. Using their expertise in science of maritime travel, Indians participated in the earliest known ocean-based trading system. Post-independence, India has witnessed considerable growth in field of science and technology post-independence. Significant achievements have been made in the areas of nuclear and space science, electronics and defense. India has the third largest scientific and technical manpower in the world. In the field of missile launching technology, India is among the top 5 nations of the world. Science and technology was brought into the mainstream of economic planning with establishment of the Department of Science and Technology in May 1971. DST today promotes new areas in science and technology and plays the role of nodal department for obtaining, coordinating and promoting science and technology in the country. Our country's resources are used to get maximum output in the field of agriculture and industry. Indian scientists are making path-breaking research in the fields of agriculture, medicines, biotechnology, cold region research, communication, environment, industry, mining, nuclear power, space, and transportation. Now, India has the expertise in the fields of astronomy and astrophysics, liquid crystal, condensed matter physics, molecular biology, virology, and crystallography, software technology, nuclear power, and defense research and development. Coming to atomic energy, the main objective of India's nuclear energy program is to use to generate power and apply the technology for further progress in agriculture, medicine, industry, and research. India is today recognized as one of the most advanced countries in nuclear technology. Accelerators and nuclear power reactors are now designed and built indigenously. Space. Indian Space Research Organization ISRO is sixth largest space research organization in the world. It has numerous milestones to its credit since its establishment in 1969. India's first satellite Aryabhatta was built by ISRO in 1975. It was followed by many more. In 2008, Chandrayaan 1 became India's first mission to moon. The Indian Space Research Organization ISRO under Department of Space DOS is responsible for research, development and operation in space through satellite communication, remote sensing for resource survey, environmental monitoring, meteorological services and so on. India is only third world country to develop its own remote sensing satellite. Electronics and Information Technology. The Department of Electronics play a promotional role for the development and the use of electronics for socio-economic development. Application of electronic in areas such as agriculture, health and service sector has also been receiving special attention. For upgrading the quality of indigenously manufactured products, a series of test and development centers and regional laboratories have been set up. These centers for electronic design and technology help small and medium electronic units. Information technology IT is one of the most important industry in the Indian economy. The IT industry of India has registered huge growth in recent years. India's IT industry grew from 150 million US dollars in 1991 to whopping 500 million US dollars in 2006-2007. In the last 10 years, the IT industry in India has grown at an average annual rate of 30%. Oceanography. India has a coastal line of more than 7,600 kilometers and 1,250 islands. The Department of Ocean Development was established in 1981 to ensure optimum utilization of living resources, exploitation of non-living resources such as hydrocarbons and minerals, and production of ocean energy. Two research vessels for V Sagar Kanya and for V Sagar Sampada are accessing and evaluating the resource potential. Surveys and exploration efforts have been directed to access seabed topography and concentration and quality of mineral nodules. India has sent 13 scientific research expeditions to Antarctica since 1981 and has established a permanently manned base Dakshin Gangotri. A second permanent station, an entirely indigenous effort, was completed by 8 expeditions. The objective was to study the ozone layer and other important constituents like optical aurora, geomagnetic geomagnetic pulsation, and related phenomena. The National Institute of Ocean Technology has been set up for the development of ocean related technologies. Coming to biotechnology, India has been the front runner among the developing countries in promoting multidisciplinary activities in the area, recognizing the practically unlimited possibilities of their applications in the increasing agriculture and industrial production and in improving human and animal life. The National Biotechnology Board was formed in 1982. The Department of Biotechnology was created in 1986. The areas which has been receiving attention are cattle herd in improvement through embryo transfer technology, in vitro propagation of disease resistant plant variants for obtaining higher yields, and development of vaccines for various diseases. Council of Scientific and Industrial Research. The Council of Scientific and Industrial Research, which is CSIR, was established in 1942 and is today the premier institution for science and industrial research. It has a network of 40 laboratories, two cooperative industrial research institutions, and more than 100 extensions and field centers. It plays a leading role in the fulfillment of technological missions supported by the government. Thank you.